Question number 4. This question is taken from November 2024 paper AS level variant 2. That is paper 1-2. The graph shows how the acceleration of an object moving in a straight line varies with time. Okay, acceleration time graph is given. The object starts from rest. Okay, which graph shows the variation with time of the velocity of the object over the same time interval. Okay, so he has given you an AT graph and asked you to find out VT graph. Simple. So now look at this. This graph can be divided into three segments. The first segment, you see there's a curve here. There's a curve here. This curve. This curve. Now how is the acceleration proportional to time here? Definitely acceleration will be a quadratic function. A will be proportional to t square. It's not linear, it's a non-linear one. Okay, maybe you can extend until here. Now this region you can extend until here. Okay, this region, what is this? This is almost a flat region. Okay, it doesn't change much. So you can say acceleration is equal to a constant here. Then starting from this region to this region, once again what's happening? Acceleration is now decreasing. There is a retardation. There is a retardation. Okay, retardation, that's once again proportional to t square. Okay, now what we'll do is let us look at this. Whenever acceleration is proportional to t square, then how will the velocity be increasing? Velocity will also be increasing in a similar way. Okay, when acceleration is increasing, velocity should be increasing. When you push your accelerator pedal on your car, definitely velocity is increasing. So as a result of this here you see velocity is increasing proportionately. So this could also be a right answer. Here velocity is increasing. This could also be a right answer. Now here you see velocity is increasing linearly over here. This cannot be right answer. Here you see velocity is increasing. This could also be a right answer. So we have eliminated C. Now let us look at the rest of the options here. Now the rest of the options, you see the first part is already been modeled. Second part, you see acceleration is equal to constant. When acceleration equal to constant, what can happen? You can see velocity would be directly proportional to time, right? Reason is dv by dt is equal to constant. Or in other words, whenever velocity is constant, whenever acceleration is constant, you can always write v minus u divided by t is equal to a, and a is constant. V varies with time. Okay, so if you recall your vt graph over here, okay, this is your vt graph, you will always get a straight line, right? V proportional to t. Now let us look at this second region where velocity is proportional to t. So now maybe we have come until here. So we have described the first part. Okay, now velocity proportional to t, there is a straight line here in this region. Maybe this can describe your first region, this can describe your second region. So this may be correct. Now here, now it is increasing like this over here. Okay, and then correspondingly, now you can say maybe similar to this one here. You can say this is your first region, this could be your second region. Okay, let us consider it like this itself. Then next one. So here definitely it is not here. Now here you see. So this I can say this is your first region. But look at this region over here. This region, once again, it is not modeled this straight line. See, if I take the slope here, I can put a tangent here. This could be the tangent. If I put a tangent here, this could be tangent. Now when it goes like this over here, now what can happen? If I put a tangent here, this could be a tangent, right? This could be a tangent. So everywhere the tangent is changing, which means what? Velocity is no more proportional to time, but it is proportional to a function of time. Okay, v proportional to t square, t cube, something. So therefore, this is also been eliminated. Okay, now let us move on to the next one here. Now if you look at between these two, now you need to look into it. Now here what's happening? Velocity is reducing here. Third part of the graph. The acceleration. When acceleration is reducing, which means what? Velocity is not increasing so much. It's still now coming down. Or it is now increasing at a much slower rate. See, velocity never reduces here. Velocity now increases at a much slower rate. Now if you look at this graph over here, velocity is increasing at a slower rate. It is never reducing. If you look at this graph here, velocity increases, then reduces over here. Definitely this is also incorrect. So A should be your right answer.